Good morning, everyone. Welcome to PyData. The topic of my talk today is creating data pipelines in the cloud. Well, that's a little bit of a misnomer because creating data pipelines in the cloud is not that very different from creating a data pipeline in your own local infrastructure. And especially with some of the tools I'm going to discuss. Well, there's one tool that's specifically targeted towards that, but when I initially came up with the topic, upon further discovery, I realized that this could be a bit of a misnomer. But let's proceed. So the first thing is first things first. Who am I? If you're a fan of Les Miserables, I would like to say I'm Jean Valjean, but I'm not. My name is Femi Anthony. My Twitter handle is displayed there. I'm a data engineer at Capital One. And I wrote a book. I've been doing work in Python for a few years now, 4 to 5 years. I wrote a book a year and a half ago called Mastering Pandas. It's available on, it was published by PacPub. It's available on Amazon. And I love coding. I guess I used to be a Java programmer for quite a few years, and then I found the data religion, and I switched to Python. I mean, people may differ as to the efficacies of one language versus another. Okay, so let's proceed. So, basic overview. I'm going to basically give a explanation of what a data pipeline is, give a rationale for why we would have a data pipeline, and really just a tool to manage a data pipeline. So I'll discuss the popular ones out there. We're all Python programmers here. The most popular one, we have Luigi, we have Airflow, and then there's AWS Data Pipeline, which is basically developed by Amazon for managing pipelines in AWS cloud. And I'll talk a little bit about usage in the cloud and an analysis of comparing one tool versus the other. So let's dive in. What's a data pipeline? Okay, so this is the era of big data, right? So from social media, smart devices, we have sensors, we have cell phone data everywhere. We have essentially hundreds of thousands of data sources, and we all sort of came to the data game, right? And with all these data sources, essentially, we basically guarantee, in terms of analyzing and processing the data, that we have a job for a very long time. That's one reason why I came to data. I mean, I like playing around with data, but it's also great job security. So we have the data scientists that basically analyze this data. And you also have engineers like us who essentially enable these data scientists to actually process this data. So, a data pipeline is really, in terms of presenting the data so that it's available for analysis, it's basically a series of software tasks that we basically source and extract data from multiple sources, disparate sources. Basically move it to a centralized location, process and transform it in a logically consistent manner. And by logically consistent, we'll talk about dependencies, right? So, if we need to source the data first, we'll need to, before we process it and so on. And produce a set of meaningful results that we can, client or end user consume, whether it's a data scientist who basically needs to use that for analysis, do some machine learning, etc. So let's consider what a data pipeline would look like. Okay, so so one of the things I like doing, just telling a little bit of myself, is my best hobby is cycling. So imagine that we're a web analytics company, right? And that company has one of its focuses is basically people who like cycling, or and the idea is that we basically you have people who do cycling or who are into athletics. There are like various sites like Strava, Map My Ride, and Endomondo is another one. And as a cyclist, there's certain routes that are very popular. So imagine that with this company that basically we'd like to see, what's the trend, what are the most popular routes, etc. They're called segments. And we basically what we do is we write some code that will basically fetch data from these providers, Strava, My so we can analyze the segments and produce maybe daily reports, maybe weekly reports. We're an analytics company. This is just one of the things that we do, okay? So, we have 3 data sources, for example, here. So, we could write some Python code that would basically specify, go and fetch data from data source 1, 2, and 3. And we're in the cloud, so we write it to S3, right? Okay, so we basically fetch the data. These are segment or log data as to, how popular or who is using, how many times were these routes, what's the leaderboard on the routes, etc. Who are the top 10 riders on this route, etc. Because as a Strava user, I'd like to know how well do I do on this route, So the next step would that be then we want to extract this data. These are fairly large logs that are on S3, and we're on the cloud, so we use Amazon's infrastructure, and maybe write it to RDS or Redshift. For those not familiar with Amazon, RDS is basically a managed Postgres and MySQL instance. Redshift is Amazon's data warehouse solution. And we have another process that is the next step, basically does ETL, okay? So basically, this ETL process, let's say it runs daily, it basically, persists that, from processes it and writes it to the database. The next step would be we do some aggregation. So we have the raw data that's essentially written to a database. And maybe our next step is we have an aggregate script, right, that basically reads that data, does some summaries of the data, across the 3 data sources, and does some aggregation, and maybe rewrites that to, Redshift itself. So that's step 3, right? So essentially, we have all these steps, that essentially have to happen in order. So for step 1, you could basically pull in all of those. They could all happen at the same time. The ETL has to happen after all the logs have been written. And aggregation will run after that as well. So let's say we, 10 most popular segments, write it to a summary table and write it back to the database. So that's step 3. And step 4, maybe it's some sort of report that we generate, and that's now presented to the end user who might be interested in that. So how do we sort of tool this? How do we, run this in a consistent manner? So let's start with what I call extremely naive approach, okay? Which would be, we're Unix guys. I guess everybody here, I assume, understands cron. We could cron each one of those jobs, right, separately. So let's say we run this at 8 a.m. We'd basically cron, and essentially all of these, the first subtasks to fetch the data from the data sources could all be croned. This is extremely naive, and at 8 o'clock, and assuming we say, hey, well, this should be done by 8:30 in 30 minutes. We'll have a next step that would read that. And suppose the ETL process, then let's say we took 1 hour. We have the next aggregate.py that would run after that. And finally, 30 minutes. Finally, the final step, let's say it took one hour. So, this is extremely problematic, as most people would know, because any of these, let's say the fetch data job, might take longer than expected to run if there is a lot of data. And if you just left it that way, the ETL will just start running on, on incomplete. What is incomplete data? So we think about it and we adopt, we took a less naive approach and we wrap all of this in a bash script, right? So the bash script would, look like the following, and basically here we guarantee that basically the scripts will be executed in sequential order, right? And they'll complete, each step will complete before the next one starts. However, that is also problematic. What if basically we have errors in an intermediate step? Let's say, that fetch data on data set 2, there was a problem and there was a formatting error or something, or basically the network was unavailable and, there was a failure. So what we could do, we could then basically add some error handling in there, right? Where we check the status of each task upon completion before we run the next one. If bash shell scripters basically will check the status. If that's 0, meaning success, then run the next step, et cetera, et cetera. So, that's a possibility, and a lot of people adopt this approach, but the problem is that this could get pretty tedious because as your data pipeline gets more and more complex, as you get more and more data, you do more and more of this stuff, it becomes really hard to manage all these scripts this way, okay? Maybe there's some sort of error, then, whoever is in charge of support has to basically wade through this and figure out, okay, well, how did the error happen? If it's a process that runs overnight, it could be basically very problematic. So so basically, why don't we sort of step back and we reconsider our approach? And possible solution that would want to use is basically use a workflow framework, workflow manager to manage these tasks. And popular ones are, as I illustrated, Luigi. Another one is Airflow. That's fairly recent. And we also have the AWS Data Pipeline, because we're in the cloud. So we're basically I'm gonna talk about these in turn and talk about pros and cons, etc. And just have a brief description of each of these. Basically, a workflow manager is essentially a tool that enables us to manage our data pipeline. So Luigi, I'm assuming we've all heard of Luigi's. We're all Pythonistas here, right? Basically, it's a package that helps build complex pipelines of batch jobs. It provides dependency resolution, meaning basically if a task depends on another to run, it manages that for you. Workflow management, it has visualization. It has a nice UI. It then enables failure handling. So essentially, if a task fails, intermediate task fails, and there's been a dependency that, okay, well, the later task is dependent on the previous one, it was not going to run that task. It basically can have you, it email you, send an alert. And it also has a command line tool, so you could run Luigi from the command line. It was created by Spotify. At that time, there weren't many tools out there, and Spotify, the guys basically worked on their own solution and decided to open source it to the community. It's currently maintained by this guy, Eric Bernardson, and it really was the first open source Python-based data pipeline manager. And it's named after the world's second most famous plumber. I mean, people who are into games, Super Mario games. Mario is the most famous plumber. Luigi is the second most famous plumber. I mean, I don't think Joe the plumber has reached that levels of fame yet. So, and the reason why it's a plumbing, because basically it's basically to manage the plumbing around data pipelines, right? So let's talk a little bit about the concept behind Luigi. One other option of also managing data pipelines, there's a tool called, people who write C code, there's a tool called Make, where you could basically express dependencies, essentially when you're compiling code in C. So that was basically expanded, since you could express dependencies on one process to another. And there have been cases where people have decided to write homegrown solutions using the Make dependency. So this is sort of similar, where you can basically have task dependencies. And essentially, you create a dependency graph. The cool thing about Luigi is that you can do all this in Python code, okay? As Pythonistas, we tend to prefer writing, essentially encoding metadata within the code itself, right? So the metadata for the pipelining is expressed within the dependency graph. And I think that's kind of cool, as a programmer. There are certain other tools like Uzi that essentially you'd use a ton of config files, XML config files, and now, XML is not really popular anymore. Another thing is that we could basically, what else it provides? It provides a UI, and it can be run in a server mode. There's a daemon called Luigi D, or you could run it in local scheduler mode. So in terms of concept, there are two main abstractions. There's a task abstraction, which essentially it's basically responsible for task execution. And basically what you do is you subclass from an abstract class that the Luigi module provides for you. It's a Python module. And you subclass from luigi.task. And the other concept is a target, which is basically a location where you write output data from each stage of the pipeline. So you can write to a local file on disk. You could write to HDFS or an S3 bucket, or a checkpoint entry in a database. So this is basically a screenshot of what the Luigi UI looks like. You basically can view, pending tasks, any tasks that are running, tasks that are done, if there are failed tasks, etc. And the other tabs, you can view a dependency graph, whatever workers are running and resources available. Okay, so let's just talk. I'm just going to talk a little bit about the task class implementation. As I said, you basically implement a task. You subclass the Luigi task, and you have to implement in general these three methods. The run method that contains the logic needed to achieve the what you're trying to do. Output method basically essentially returns what your target is. And as I said, the target object could be a local file object and S3 object. And all required is where we actually specify what the dependencies are, right? So if task B depends on A, you specify that in there. So here's an example of, sort of the final stage in our pipeline, where we basically generating a report. We can specify parameters to the task, with the Luigi.parameter call there. And so one thing is that essentially these run, requires, etc. These are calls to other, basically like we specify we want to call gen report there. And I didn't show that part where, essentially that module where basically it specifies you want to run gen report. And if you remember, if you go, back, that the prior task to report task was basically our aggregation. You basically aggregate task would be defined elsewhere in a similar manner to report task, where we basically subclass in Luigi.task. And then our output would basically specify, let's say we're writing to S3, writing the report to S3, you basically would use the end date and a bucket that we've defined. I didn't show that there. And basically, we're returning that as the target. And here's how we would specify, if we wanted to call this task at the bottom. So examples of targets, you could basically create your own target by inheriting from Luigi.target. There's just a couple of S3 target, an HDFS target, and a local target, which is we're writing to a local file. And many other targets are specified in the documentation. So I'll talk a little bit about the advantages of Luigi. It's mature. It's been around the block for quite a while now. It's platform agnostic. So, we're not limited to, like, let's say Uzi, which is really focused on something like Hadoop. It has a lot of native support for, HDFS, S3, Postgres, MySQL. So it's fairly mature. It's fairly rich. The UI is I feel it's not necessarily the best, but it's a decent visualization UI. And the dependencies are decentralized. We're not as tightly coupled as let's say, other tools. So some of the limitations, we don't really have a built-in task triggering mechanism. Basically we have to rely on a cron or some other scheduler to trigger a pipeline run. The focus is it's a really tool that I guess all of them are focused on batch processing, so it's not as useful for stream processing or real-time pipelines. Basically, I've found that you could really just write a small number of tasks, specific tasks, because you basically writing, like a task for like a very specific. Basically, you have to subclass Luigi.task. It could get a little tedious, in terms of managing that. That's just my experience, but some people might beg to differ. And we basically write the persists of, to a file at every stage. You can't really like send output from one stage to another, in memory. But some of these limitations may be in the eye of the beholder. So let's go to Airflow. So Airflow is basically, again, a workflow management and orchestration tool that was written in Python. It was created by folks at Airbnb. It's currently maintained as an Apache Foundation project. And, it's got a large set of features. It's got a rich UI. It has a scheduler, command line interface. And also it basically uses a task manager like Celery. It's the one that's recommended. So some of the design principles behind it, the core abstraction is a DAG, a directed acyclic graph. So basically the pipelines, basically a directed acyclic graph would basically be used to capture the dependencies, if one task is dependent on another, and all the way down to the end of the graph, the final stage. And each task is a node on the DAG. The dependencies are basically the paths that connect the nodes. Obviously, you can allow cycles. That's why we have a DAG, so that the pipelines can complete. And if you end up basically encoding a cycle, basically Airflow would raise an exception. Or if a dependency is referenced more than once, basically you got an exception. So you can run tasks that are independent in parallel. And task failures in independent parts of the pipeline don't derail other parts. So essentially you have you don't have, if a task fails in one part, the rest of the in one part of the pipeline that's independent, it basically doesn't derail other parts. And you could basically rerun parts of the workflow. It's fine-grained, that have been affected by failure. So the components, you have job definitions, which in general, you persist them to store source control. There's a metadata database component. So this is one of the things that, I guess, increases management complexity, because in general, like in production, out of the box, basically, you have the metadata database is SQLite, but in a production environment, you'd want to store it in a serious database like MySQL or Postgres. And basically, what that database is stores metadata, and sort of like the status of tasks that have been run. There's a rich command line interface, and this allows you to test, to run, backfill, and if you want to run a backfill, let's say you implement your data pipeline and you want to backfill parts of the pipeline by running, let's say for example your pipeline is date dependent. You might want to run previous dates, so you could basically run a backfill with that. And the web interface is fairly rich. You could use it to view task dependencies, logs, statuses, and metadata. And that's implemented as a Flask web app. It's fairly self-contained. So when you install Airflow, you get all of that for free. There's a scheduler. So in the case of Airflow, you don't have to depend on cron. And that basically is used to run the kickoff tasks. And the final component is basically your workers, which is basically processes that can run and essentially make use of a distributed architecture. So I think this is it's a fairly new tool, but it's very comprehensive. And it takes some time in terms of getting up to speed on it because it's so large and so rich. And this is just a snapshot of what the UI looks like. These are tasks, scheduler. It's as I said, the learning curve. You basically, because it's so rich, it could take a while for you to get really competent and great at this. I'm not claiming myself to be an expert in this in any way. So concepts around Airflow. We have operators. They basically allow you to create certain types of tasks. There's a base class called base operator, and you can inherit many attributes. So examples of operators, a bash operator, if you want to run basically bash scripts, a Python operator for writing Python code, which I guess most people would be interested in, the email operator, and again, these are comprehensively detailed in the documents, a lot of documentation there. And then executors are the mechanism by which you can run tasks. So again, there's a base executor class, and then some examples of executor, local executor, sequential, and Celery, if you're basically using Celery so basically as a task management task queue. There's also a Mesos executor as well. I haven't used it, but that's available. Again, all of these are detailed in the docs. So that's how here's how we could create two tasks. So task A and task B with, task B dependent on task A running. So, you import the Airflow models, and then basically import a DAG. You basically import the DAG module, and you could then specify that DAG. Basically, you could create a DAG with various arguments that I haven't, for interest of space, I didn't but basically you can have default args that you pass to the DAG. And essentially, in terms of tooling, essentially because we're tooling here, you specify that this task is a Python task, and what module should be called, and you specify a task ID. along with the DAG. And the task B again, you basically have another module that's for task B, and that's how you define that task. And to basically specify a dependency, you specify call setup stream, and that says, okay, task B is dependent on task A running successfully. There's another function called set downstream, and in that case, you basically task A and task B, you basically will be switched. So that's just another option. So basically, you'll be task underscore A dot set downstream task underscore B. So one thing is that this is the DAG definition file, and we're not really, this is basically just for tooling. It's not really doing our data processing. So basically what this script is, basically we're defining what our DAG looks like. And basically we'll call run Python on this script, and to basically pass the DAG and essentially save what the status of the DAG is. And then we'll basically run Airflow to actually execute the task, execute the pipeline with the name of what the task is. So let's say that would, the end of the pipeline will be task B. So you do Airflow task B, and it would then execute and realize as a dependency, and task A will be executed before task B. So there's a lot here. I haven't shown all of it, but there's a lot involved with Airflow. Again, to really get competent at this, you'd have to basically play around with it and do a lot of reading of the docs. So another nice thing about Airflow is that you can basically have dynamic task creation. So let's say, for example, you wanted to run something on a set of files. You basically want to execute the same operation on the set of files. And these files, were parameterized, the names are parameterized in some way. You basically could have a set of tasks that essentially run on each file in a loop, and they were dependent on a previous task, task A. You'd basically run one that, and I'm not really sure how easy that is to do in Luigi, but Airflow, we can do that very easily. Another thing is that there's this concept of macros in Airflow. So you basically can have abstract this even further and specify parameters and essentially generate hooks for whoever is writing the pipeline to define their own parameters and really templatize this. I haven't shown that here, but again, that's another powerful feature of Airflow. So, yeah.
From that dynamic flow, can you run a file that is not Python file?
Okay, so for example, so when you say that's not a Python file, so you remember we had operators, right?
Yeah.
So let's say you had one that was a bash script. That would be, Python operator would be replaced by bash operator.
Okay.
So there are various operators.
This would be a bash script.
Yes, yes. Okay. So it's written in Python, but you could have all these operators that specify, well, this is bash, that's, etc. Again, the universe of this is a lot. I am nowhere an expert in this. This basically, I wanted to explore and examine, Yes? Yeah, it's a distributed system, so I suspect so, but I haven't really done that. And again, I would have to look at you'd have to look at the docs for that. But well, you could pass parameters, right? I think I showed how you pass in Luigi. You could pass parameters there. So I'm assuming, remember, this is really, we're tooling here, right? So it's not like we're implementing, okay, processing within the Luigi task itself. We're basically passing parameters around. So something like a database, you could tell it, well, maybe read from here or pass it in, and pass the parameters and call a Python script, etc. All right, I guess I'm running out of time here, so let's move a little faster here. Okay, so advantages, I think for Airflow, it's very comprehensive. You could do programmatic authoring of pipelines. Again, that's an advantage over stuff like Uzi. I think the CLI and the web UI are very rich compared to even Luigi. And if I had to write a pipeline now, with this tool that was fairly complex, I think I could express that in Airflow. It's very powerful, because you can express DAGs within sub-DAGs, within DAGs, etc. So disadvantages, it's architecturally complex, lots of moving parts. If you have to, let's say you're in production, you have to manage a MySQL database, make sure, there's possible points of failure there. A scheduler, if you have a salary queue to basically manage, essentially schedule, manage tasks. And I think it's a little bit more complex in terms of getting getting your head around the code. I don't think it's as easy as, getting up to speed in Luigi. So let's talk about AWS Data Pipeline. So that's a web service-based manager for managing data pipelines created using Amazon Web Services. It's a little different from the other two. It's more similar to Microsoft SSIS. It's not really geared for Python, writing code in Python, although you could do that. It requires an SNS endpoint, and it's essentially an ETL process that's hosted on Amazon's cloud. So the emphasis is more on a UI-based pipeline creation and management rather than a programmatic approach. So you basically, if you're familiar with Amazon Web Services, you'd basically go in and click and essentially define a pipeline. Like if let's say you wanted to create, akin to if you were creating an RDS instance or EC2 machine, you were configuring that. So it's very UI-oriented, and as programming Pythonistas, it's not, at least it's not my cup of tea. Other people might beg to differ. You can still use APIs. Yes, you can. Yes, you can. But I looked at the documentation. It is not fun to deal with. Okay. You can. It's just your learning curve is, the SDK. So, I'm going to go into that. So this is basically what the UI would look like in terms of creating a new pipeline. Okay. So again, you use the management console to manage the pipeline. You have a AWS CLI interface. I'm sure folks are familiar with that. And what you mentioned, the SDKs that are provided. Not many examples in terms of if you're using Python, because I really tried to figure it out. And after a while, okay. And so essentially, there's a Boto3 module that essentially is an implementation of AWS CLI. And you could basically, essentially, tool your own and come up with your own. It's just trying to figure out how that works compared to something like Luigi. There's a much steeper learning curve than Airflow. And there's also a query API. It's a low-level API, but I'm not familiar with it. And great, this is how a pipeline definition file looks like. So if we're trying to basically create one, etc. This is JSON. It looks very complicated. I don't know, some people may beg to differ, but that doesn't look like fun to me. So advantages is if you are sold on AWS completely, it's got seamless integration. You can use S3, RDS, H2FS. The web UI, if you like pointing and clicking, you can use that to create pipelines. The emphasis is on config files. So maybe non-programmers or people who like staring at JSON files might like that. And you don't really need to install additional software if you're in AWS. It's just available for you. But doing a pip install Luigi, pip install Airflow to me is very simple. So I don't really, Limitations, there's tight coupling with AWS services. So essentially you have vendor locking, right? So we like to think at Capital One, we use AWS, but theoretically we like to think that, hey, possibly we might want to do this on Google Compute Engine. Now you do all this in pipeline, in AWS pipeline, you're essentially locked in. I hate vendor lock-in. Sometimes I guess you pay for services you may not want to use, like Dynamo example. So it's not very programmatic, it's more configuration file-based. Again, you can program it, but again, to me, I think it's hard to do that. And I don't think you can specify dependencies in Python code as easily as you do in Luigi Airflow. So to launch pipelines in the cloud, you basically, Luigi Airflow, EC2 instance, you install Python, people install Luigi, people install Airflow. And AWS Data Pipeline, I already showed you, we could basically go in and configure it. I'm running out of time here. Yeah, 5 minutes. So this is just a comparison of my opinion here. People may beg to differ. All three of them. To me, it's easy to use Luigi, more moderate. And for AWS Data Pipeline, it depends. Because, hey, if you're somebody who likes pointing and clicking, you might find it easier. If you're somebody who prefers programming rather than generating config files, so that's why I said it depends. Programmability, Luigi, I say medium. Airflow, probably high. AWS pipeline, meaning how programmable is it? I said low because, again, it's hard to find examples or samples to do this. Complexity, Luigi is low, etc. And I would say moderate. And coupling of which to me is important, high coupling, and there's no coupling at all. I would say the costs are probably about the same. Developer learning curve, Luigi, I think is, low, moderate to high. There. Okay. So conclusions, I would say use Luigi if you essentially have you want to get up and running quickly, your workflows are relatively simple. You want a minimalist workflow management solution that is also programmatic, and a tried and tested solution which you have a vast knowledge base of solutions, out there on Stack Overflow, etc. Airflow, if you want an all-in-one solution, you don't want to have to deal with cron. You have a complicated workflows with many dependencies, and again, you want to have your dependencies encoded in code, Python. AWS, if you are totally sold out and having everything in AWS, you don't mind configuration and UI-based pipeline solution, you would like an all-in-one solution that seamlessly integrates with AWS services. And here are some references out there. The slides will be made available, and that's the summary of my talk. Excuse me if I wasn't as polished. This is my first time doing this with an audience so big, so
Are there any questions? We have 3 minutes.
In Airflow, do you know what kind of so in Luigi you can pass like files and database rows and stuff between tasks. Do you know what sort of system Airflow has for that? What can you pass between tasks?
You know, like how you could basically specify a target and do that in Airflow. I have to look it up. Sorry, it's just there's a lot in terms of looking. All right. Okay. Thank you. Thanks, everybody. Thank you. All right.